Hello friends, I welcome you in lecture number 35 on group theory. In this lecture we will discuss this question which was asked in GTU Winter 2020 exam. First we understand what is the question. Check the properties of commutative and associative for the operation star defined by x star y equal to x plus y minus 2 on the set Z of integers. So here we are given one binary operation and we have to check whether that operation is commutative and associative on the set of integers or not. So we are already familiar with the definition of commutative and associative binary operation. We just recall that a binary operation is commutative if for any two elements in a given set x star y equal to y star x, and binary operation is associative if we take any three elements, say x, y, z, then if we change this grouping, if we consider y star z in the bracket or x star y in the bracket, these two are always equal for any three elements x, y, z in a given set. So here we are given one binary operation star on the set of integers and we have to check whether that binary operation satisfies these two conditions or not. So first we check for commutative property and then we will go for associative property. So here we write that first we are checking for commutative property. So we start by writing in this way: commutative property. Given set is set of integers. So for commutative property I have to check whether x star y equal to y star x or not for any two integers x and y. So I start by taking two integers x and y in the set of integers. Let x, y be any two elements in the set of integers. Then by the definition x star y, here we apply the definition of given binary operation. X star y is defined as x plus y minus 2, first element plus second element minus 2. So here we write x plus y minus 2. Now we know that addition is commutative binary operation, therefore we can write x plus y equal to y plus x. Okay, here we are using the fact that standard addition on set of integers is commutative. We know that x plus y equal to y plus x for any two integers x and y, and by the definition of given binary operation this is equal to y star x. Our operation is x star y equal to x plus y minus 2. So if I am writing y star x, then here I will write y plus x minus 2. Therefore I have replaced y plus x minus 2 by y star x. So we have proved that if we take any two integers x and y, x star y equal to y star x. Therefore we write that x star y and y star x are equal for all x, y in the set of integers. Therefore we have proved that operation star is commutative on this set of integers. Now we check for associative property. So now we write in this way. We have written commutative property first and now we are checking for associative property. So in the next point our heading is associative property. For associative property we have to consider three integers. So first we try to prove this property, and if we have any difficulty in proving the property then we will take counter example. Suppose I start by taking three integers x, y and small z. Now I don't know whether associative property is going to be satisfied or not. So what I can do is, first I can try to prove this property, and if there is some difficulty in proving that property, then I may have the idea that this property might not be satisfied on the set of integers. So if I have some difficulty in proving the property, then I will start by taking three particular integers and then I will check for those particular integers. So this is the way how we should check properties of binary operation. So first we try to see what we will obtain for this part, x star in the bracket y star z. So this is equal to, now our operation is x star y equal to first element plus second element minus 2, x plus y minus 2. This is given binary operation. So using this definition, with instead of y here, I will use y star z. I will consider this as second element, this as first element, and our operation is first element plus second element minus 2. So here I will write x as first element, second element is y star z minus 2. So this is using the definition of binary operation which is given. Again I apply this definition for y star z. So for that I will write y plus z minus 2. I will replace y star z by y plus z minus 2, and minus 2 is there. So this is equal to x plus y plus z minus 4. Now I check other side. Here I have taken y and z in the bracket. Now I consider x and y in the bracket, and let's see what we will obtain for this side. Now we consider x star y star z. Again by definition of binary operation, this is x star y, that is first element, z is the second element, minus 2. Now again we use the binary operation. X star y can be written as x plus y minus 2 using the given binary operation, plus z minus 2. And we know that addition is commutative, and here we can write using the commutative property. This we can write as x plus y plus z minus 2 minus 2, that is minus 4. So we can see both sides are equal. We give this number 1, this is number 2. So from 1 and 2 we can observe that associative property is also satisfied. From 1 and 2, x star y star z equal to x star y star z, because right hand side is same. For this we obtain x plus y plus z minus 4, and here also we obtain x plus y plus z minus 4. So because right hand sides of 1 and 2 are equal, left hand side must be equal, and these x, y, z are arbitrary integers. So this is true for any possible 3 integers, for any x, y, z in the set of integers. Therefore we have shown that star is associative, or binary operation is associative on the set of integers. So this is very easy question. You just have to check two properties of commutative and associative for given operation on the set of integers, and we have just used the definition of binary operation which is given, and we have used definitions of commutative and associative property, or we must know that when our binary operation is commutative and when it is associative, and we have frequently used this property. We know that addition on the set of integers is commutative, and if you recall, we have shown that z with addition is an abelian group. Therefore we can write x plus y equal to y plus x, because addition is binary operation on the set of integers and it is commutative. So in this way I have proved these two properties on the set of integers. So this is all about this session. I hope you like it. Keep watching.